Good morning, students. Today we will discuss some examples based on the topic pressure at a point. So our first problem is a small uniform tube is bent into the form of a circle whose plane is vertical. Equal volumes of the two fluids having the density rho and sigma, they fill the half of the tube. Show that the radius passing through the common surface makes with the vertical an angle theta given by tangent theta is equal to rho minus sigma upon rho plus sigma. Now let us see this diagram. This represents a small uniform tube which is bent in the form of a circle, and the plane of this circle, that is vertical. Because we are given equal volumes of the two fluids are filling the half of the tube. So this portion that shows half of the tube. AB is diameter of the tube. Because the volumes are equal, so we can take the column AE that represents the volume of the first liquid, and this is making an angle 90 degree at the center because this line is straight line, so the whole angle that will be 180, and volume of the two liquids are same, so we can take these angles to be 90 each. The second liquid that is represented by the column BE, and also this angle is 90 degree. We are to show that the radius passing to the common surface, this is the common surface of the two liquids, and this is the radius passing through the common surface. We are to find the angle of this radius with the vertical, means this angle theta. We are to find tangent theta, and we are to prove that it is given by rho minus sigma upon rho plus sigma. Because this angle is theta, this full angle is 90, so this angle will be 90 minus theta. Here these two angles are vertically opposite angles, so this angle will also be 90 minus theta. Density of the first liquid, which is in the column AE, we have taken as rho, and density of the liquid which fills the column BE, that we have denoted by sigma. Now let us apply the condition of equilibrium. Because the fluid is in equilibrium, so we can say that the pressure at this point D due to the column AD, that will be same as the pressure at the point D due to this whole column BD. So let us find the pressures. Now the pressure at the point D due to the column AD, that is given by rho into G into the distance MD. On the right side, the pressure at the point D due to the column BD. Here BD is consisting of two parts. One part is the column DE, another part is BE. So the pressure due to the right side, that will be rho G into this length ND, plus the density of this liquid is sigma, and the depth is Ln, so that will become sigma into G into Ln. Now from the figure you can see what is MD. MD is given by OD minus OM, and ND, that is given by ND is OD minus ON. So we can put the values here. OD is the radius of the circle which we have taken as A. So this equation becomes rho into A minus OM is equal to rho into A minus ON, or plus sigma into OL plus ON. Now we are to find OM, ON and OL. Let us find them from the right angle triangles which we have shown in the figure. Now from the figure OAM, you are to find the value of OM. This is the base of the right angle triangle. This is hypotenuse. So base upon hypo, that will become cos of the angle. Here angle is 90 minus theta. So OM upon OA, that is cos of 90 minus theta. So from here OM becomes OA into cos of 90 minus theta. OA, that is the radius which we have taken as A. So OM will become A cos of 90 minus theta. Now to find ON, you can use the triangle ONE triangle. From this triangle, ON is the base, O is hypotenuse. So ON upon OE, base upon hypo, that is cos theta. So ON will be OE into cos theta. OE is the radius of the circle, which is A. So ON becomes A cos theta. Now we are to find the length OL. Now you can find OL from this right angle triangle. In this triangle, OL is base, OB is hypotenuse. So OL upon OB, that will be cos of this angle. So OL upon OB is equal to cos of 90 minus theta. OB is the radius of the circle, which is A. So OL is equal to A into cos of 90 minus theta. So we have obtained the values of the distances OM, ON and OL. Now we can put all these values in the equation. So our equation becomes rho into A minus A cos 90 minus theta is equal to rho into A minus A cos theta plus sigma into A cos of 90 minus theta plus A cos theta. We can take A common throughout and we can cancel A. So we get the equation rho into 1 minus sin theta is equal to rho into 1 minus cos theta plus sigma into cos theta plus sin theta. Now we can combine the terms in rho on the left hand side and the terms in sigma on the right hand side to find the value of rho upon sigma. So rho upon sigma, that is given by cos theta plus sin theta upon cos theta minus sin theta. Now according to the requirement, let us apply componendo and dividendo rule. So this will become numerator minus denominator upon numerator plus denominator. So this will become rho minus sigma upon rho plus sigma. On the right hand side, a numerator minus denominator, that will become cos theta plus sin theta minus cos theta plus sin theta. In the denominator, we will have numerator plus denominator, that will become cos theta plus sin theta plus cos theta minus sin theta. So we get rho minus sigma upon rho plus sigma is equal to 2 sin theta upon 2 cos theta. Sin upon cos, that is tangent, so this will become tangent theta. So we have shown that the radius passing through the common surface makes with the vertical angle theta, which is given by this expression. Now our next problem is a closed tube in the form of equilateral triangle that contains equal volumes of the three liquids which do not mix and is placed with the lower side horizontal. Prove that the densities of the liquids are in AP, then the surface of separation will be at a point of trisection of sides of the triangle. So let us discuss the figure firstly. Now here the triangle ABC, this represents a closed tube which is in the form of equilateral triangle, because this tube contains equal volumes of the three liquids. So for one of the volume we have shown in this portion from this side to this, and second liquid we have shown till the point D, and third we have shown from starting from D to the end E. So these three parts, these are showing the equal volumes of the three liquids. This tube is placed with lower side horizontal, this side BC, that is horizontal, and we are given densities of the liquids are in AP. So we have taken the three numbers in AP as the densities rho minus delta, rho and rho plus delta. The liquid with highest density we have taken in the lowest side. rho plus delta that we have taken in the lowest side. We are to prove that the surface of separation is a point of trisection of sides of the triangle. It means if we take this distance as x, we are to prove that x is 1/3 of this whole side BC. If we denote the length of the side of equilateral triangle as a, then we are to show that x will be a upon 3. Now, as we discussed in the previous question, because the fluid is in equilibrium, so we can apply the condition of equilibrium. Also the side BC, that is horizontal, so pressure at B will be same as pressure at C. So let us find the pressure at the point B and the value of pressure at the point C and equate the two. Now the pressure at the point B, that is given by the density of this liquid, that is rho plus delta. So pressure will be rho plus delta into G into depth of this liquid. You can see here this is Mn. Now the pressure due to this liquid is having the depth Am and density is rho minus delta. So the pressure at the point B due to this part of the liquid, that will be rho minus delta into G into Am. So this part represents pressure at the point B. Now the pressure at the point C, here the density of the liquid, that is rho minus delta, and the depth of the liquid is Al. So rho minus delta into G into Al. Density of this liquid, that is rho. So rho into G into depth of this liquid is Ln. Now we are to find the values of Mn, Am, Ln, Al. Now from the figure you can see what is Mn. Mn is given by An minus Am, and Ln is this part. This is given by An minus Al. Now we are to find the values of An, Am and Al. So again let us use the triangles concept. In the triangle ABN, AN is perpendicular, AB is hypotenuse, so perpendicular upon hypo, that will be sine theta. In equilateral triangle each angle is 60 degree. So AN upon AB, that is sine 60 degree. AB is the length A, so AN is given by A sine 60. Now to find AM, you can use the triangle AFM. In this triangle AM is perpendicular, AF is hypotenuse, so perpendicular upon hypo, that will be sine 60. The length AF, because this whole length is A, this part is X, so AF will be A minus X. So putting the value here, this will become AM upon A minus X is equal to sine 60 degree. So value of AM is given by A minus X into sine 60. Now it remains to find the length AL. Now from this triangle ALE, AL is perpendicular, AE is hypotenuse. So perpendicular upon hypo, that is sine 60, and this length is X. So we get AL upon X is equal to sine 60. So the value of AL will be X into sine 60. So we have obtained all the distances AN, AM and AL. Now we can put all these values in this equation. So we get rho plus delta into AN plus minus rho minus delta plus rho minus delta into AM is equal to rho minus delta minus rho into AL plus rho into AN. Now we can combine the terms with AN on the left side. That will become rho plus delta minus rho into AN. On the right side we have 2 delta into AM minus delta into AL. So cancelling out the term delta throughout, we get AN is equal to 2 times AM minus AL. We have obtained the values of all the three terms, AN, AM and AL. So putting the values here, we get A sin 60 is equal to 2 into A minus X into sin 60 minus X sin 60. So from here we get A is equal to 2A minus 3X. So we get 3X is equal to A. So we get X is equal to A by 3. So this proves that the surface of separation is at the point of trisection of sides of the triangle. So this completes the solution of this problem.